Thanks. Hi everyone. How you doing? Good? Not sleeping yet? So yeah, I'm going to talk about something called ML Kit for Firebase. I guess just a quick survey, who's heard of ML Kit? That's fine, okay. So you probably know all this stuff already. So I guess the catchphrase for ML Kit, in case you haven't heard of it, ML Kit brings Google's machine learning expertise to mobile developers in a powerful and easy to use package. And for those of you who have used our other Firebase products, hopefully you've had a sort of satisfying developer experience. I think it's a pretty good developer experience. Always like really easy to use APIs, really nice documentation, and usually really quick to get up and running doing something really powerful in your mobile apps. And ML Kit tries to follow that same kind of pattern. Okay, so what is ML Kit? We offer APIs for both Android and iOS. So that's kind of a theme of Firebase. We always want to make sure we support both platforms. And there's really two main components to ML Kit. There's something we call the base APIs. And these are kind of just common use cases that use ML tech. Some of the things that Anka mentioned in his talk. And they're already pre-trained by us, ready to use, wrapped up in nice APIs that you can put into your mobile apps. Now you might be thinking, well, we've already got all these other products, right? We've got some mobile ML type APIs, we've got cloud-based ones. Why does it have to be yet another one that you have to use? Well, the answer to that is it's actually not another one. It's really just wrapping up the APIs so that you can easily build it into your mobile app. So behind the scenes, it's always going to call our cloud ML technology, or it's going to use the on-device technology as it needs to. So it's just presenting it in a really easy-to-use fashion. These base APIs can be both on-device, the inference runs on the device, and cloud-based as well. And then the second section to ML Kit is something called custom models. So this is where you can actually take a TensorFlow-like model of your choosing, so you can go and build it yourself or use one that's already existing and load it into your mobile app. Now you might be thinking as well, there's these TensorFlow Lite actually has APIs for Android and iOS as well, so why would I want to use this? Well, again, we make it really easy to get up and running, so really nice Firebase APIs. And we add a bunch of conveniences as well that make it sort of much easier for you to actually build this into a production app. So we have things like working nicely with other Firebase products, things like A/B testing, so you can test different models. And we also have unique features coming soon, things like experimental model compression, which will let you configure your model and be able to compress a larger model into a smaller space so that your mobile apps can still remain small and fast for your users. Okay, so I'll walk you through the base APIs. I'm going to go a bit quickly because I think most of you have sort of seen some of these before. So these are the kind of base APIs that we have. Text recognition, image labeling, barcode scanning, face detection, and landmark recognition. And we have a new one that's coming soon that we announced at Google I/O, but it's not ready quite yet, called Smart Reply. So this is kind of what they look like from an on-device versus cloud perspective. And the reason why they kind of split like this, it really just comes down to the use case. Some of them just don't make sense to be sent up to the cloud and come back down again. And likewise, others don't make sense to be able to run on the device because the model might be too large or too complicated to store on the device. Okay, so text recognition, pretty common use case. We can run this one on the device or in the cloud. If you do it on the device, you get things like text, bounding polygon, Latin characters, and it's free because it's running on the device. And if you move up to the cloud version of it, you improve the accuracy of that, you add languages, special characters, so on. And there is a free quota, but then of course it's going to be paid because it's going to reach out to our cloud infrastructure. And this is just a quick demo of what it looks like using one of our demo apps. You can see here it pretty quickly can capture the frames, run the inference, and process the text. Okay, the second one is image labeling, another very common use case. However, of course, if you've got a specific type of image labeling in mind, this may not be useful for you because it's going to have very general terms. If you use the on-device version, there's going to be 400 labels. And the nice thing is you get links back to Google's knowledge graph. So Google's knowledge graph is sort of a link out to our database almost of information about those labels. And as usual, the on-device version is going to be free. The cloud-based one will expand those labels further, and then it turns into a paid product after a free quota. And just as an example, this is the kind of differences you're going to get with the on-device version versus the cloud version. So at the top, you'll see the sort of labels for this image for the on-device version, and at the bottom, the cloud labels. Okay, the next one is barcode scanning, and this one is on-device only, and so it's free, running inference on the device. And this is pretty cool. Actually, you don't need to specify which barcode format. It detects which one it is. It works in any orientation. And the nice thing here is it does some extra work for you as well. It extracts any structured data. So, QR codes can store things like URLs or contact information. So it's going to give you that information as well, all in this really nice, easy to use API. You can see an example running here. Okay, face detection, maybe for some more fun type applications. Now, we actually recently added a new feature to this, something we announced at Google I. It's called face contours. And it's actually just become available in the last few weeks. So you can see an example of that on the right side. But yeah, what this will do is it'll give you the bounding polygons of various facial features. It'll give you things like if the eyes are open or closed. It'll give you head rotation. It'll give you if the person's smiling or not, and it can support multiple faces in the frame as well. And with the face contours API that you see here, without using any extra information other than just the image, you can plot this sort of three-dimensional contours array across the user's face. Landmark recognition, this one is cloud only, and the reason for that is just bringing the model down onto the device is probably going to be too large for most applications. And I think Anka talked about this before, how this works, so it's kind of as you'd expect. And then the last one is Smart Reply. So this one's not available yet, but it's coming soon. And the thing I really like about this one is, in terms of using the API, it's so simple. You just give it a string of text, like a regular string object, and it will derive these smart replies that you can include into your app, along with a confidence score. So you can sort of work out at which threshold you want to show those replies or not. Okay, so just to give you an example of how quick and easy it is to use these APIs, I thought I'd take you through a quick implementation. So iOS and Android both support it, as I mentioned. First thing to do is just add your dependencies. In iOS, that will be in your pod file. In Android, that will be in your build.gradle. And then for a vision, the Firebase Vision Label detector, you can go and grab an instance, super straightforward. And then you have to create the input, which is just an image in this case. And we have this class called Firebase Vision Image, which lets you pull that image in from a variety of sources. One of them can be a file path. One of them could be the bytes in memory. So like if it's coming directly from a camera buffer or something like that. But whatever it is, you need to give it the data. So this is how we form the data. And really, that's kind of it. Now you actually go and run the inference, and you get back something called a task. For those of you who haven't seen a Firebase task before, it's really just an asynchronous callback request. So we call it detect an image with the data. And you just get the callbacks at some point later. So you get on success, on fail. And in this particular case, we're going to get Firebase vision labels, which are basically just the text label along with a confidence score. And the really nice thing here is, so this is using the on-device version. And the on-device version is going to run pretty fast, like in the order of magnitude of milliseconds, right? But if you want to use the cloud version, you can as well. So if you look at the cloud version, so that's the on-device version, and this is the cloud version implementation. It's exactly the same. It's just using slightly different class names, which have the cloud name in there. But otherwise, implementation is exactly the same. And of course, the asynchronous request is going to take longer in this case, right? It has to send the bytes up to the cloud, do something, and pull them down again. But for all intents and purposes, it's exactly the same code. And this is really what ML Kit's trying to provide, like really easy APIs. You can use them, cloud, on device, whatever suits your purpose, it's ready to go. Okay, so let's move on to something a bit more interesting, I think, is the custom model support. So if the built-in use cases don't really work for what you're trying to do, you can also use custom models. Behind the scenes, this is actually based on TensorFlow Lite. So if you already have been using TensorFlow and you've already been experimenting with TensorFlow Lite, you're kind of ready to go to use this with ML Kit. And behind the scenes, TensorFlow Lite uses some lower-level APIs at the system level. On Android, it'll be the NN API, the Neural Networks API, which is a low-level hardware-accelerated API to make sure everything runs faster on the device. And on iOS, it'll run on Metal for hardware acceleration. And some of you might be thinking, well, why doesn't it run on Core ML, which is Apple's ML framework? And that's just because a standard TensorFlow Lite model is not directly compatible with Core ML. There is a way to convert it, but some of the operations aren't necessarily compatible, so there's some work to do there. But it still does run hardware accelerated through the Metal APIs. Okay, so how do you actually use the custom models? Well, through the console, the Firebase console, there's really not that much to do. Go there, go to the ML Kit section, click Add a Custom Model, you give it a name, and you upload your model. That's it on the server side. Now, when it comes to the code, I know this looks like a lot of code, but it's actually pretty straightforward as well. It's definitely not as straightforward as the base APIs I showed you before, so just bear with me here. So the way that custom models work is you do have to provide it a bunch of information so it knows about the models, what the input and output is, how to run the model. The first thing you have to do is register the cloud and or the local model source. So what ML Kit lets you do is you can run a local model that's included in your binary, or you can reference the cloud model that's based in the Firebase console, or you can do both. Okay? And if you do both, it's going to use the local one first, and in the background it's going to go and pull down the remote one, and then it's going to replace it when it can, as it can. And it does all of that for you automatically. You just have to tell it where to get those models from. And that's what's happening here. So the top section is defining how to get the cloud model. And you can see here you can give it a bunch of parameters. So you can say enable model updates, and that means as you publish a new model to the Firebase console, it's going to automatically go and fetch that for you in the future. You can give it a bunch of conditions for how it does initial and updates. So it has to be on Wi-Fi, has to be plugged in, has to be idle, whatever you want. And then you register it. And the local model is the same, but less parameters. So you can refer to your assets directory in Android. You could also refer to any disk location. So if you want, you could pull the model down from your own server separately, store it on disk, and then reference it using this local model instead. So the choice is up to you. Okay, and then here we just use this thing called Firebase Model Options Builder to actually go and tell it about those models. And then we've got our interpreter, our thing that's going to run the inference on the device, Firebase interpreter here. So next step is actually running the inference, right? Now, because a model is just going to take a sort of arbitrary set of bytes in and send out an arbitrary set of bytes, we need to tell ML Kit exactly what structure those bytes are expected to come in and what structure they're expected to go out. So here's an example. So you can see he set the input and the output format. In this case, this input format is a pretty standard kind of image input. And what you see there is 299, 299, and 3 is kind of like a 299 by 299 pixel image with a depth of 3, so the colors in an image. And obviously, you have to know this information for your model, so it's up to you to work this out. And the output in this particular example is going to be a set of labels with confidence scores. So there'll be 1,000 labels in this case that can be returned. And so the very bottom section is where you actually get the input and provide it to the model. Now it's only like a few lines of code, and you might be thinking, oh, that's super easy. But again, it's really up to you here to transform the input from the user or from anywhere else into sort of this byte format that you've set here in set input format. So for an image, that might mean like looping through your image and transforming it in some way so that it's in a format that's suitable for your model. And then lastly, we're going to run the inference, and we just call our interpreter.run, and we give it all of this information, the inputs, the input-output options. And again, it's just an asynchronous callback, a task, a Firebase task. And on success, we're going to get that output format that we defined. Failure, we're going to get an error that we can follow up with the user. So a little bit more complicated than using the base APIs for sure. But if you look at how to load a custom model onto a mobile app, this is probably one of the most straightforward ways you can get. So a few caveats. Obviously, you have to have the model, right? So that can be a very hard challenge in and of itself. And then, as I mentioned, fetching the input and then converting it into a good format is actually quite difficult as well. So for example, if you want to take the camera buffer and capture every frame you want to convert it into those bytes and then send it through, there's going to be some work there to make that work well, and it's up to you to do that. ML Kit won't handle that. And some of you might be thinking, well, wouldn't it be great if ML Kit could do that as well? Well, in this case, for custom models, we want to leave the flexibility up to you. So if you want to process sound, like identifying frogs, for example, in the last talk, then you could get a sound file and convert that into whatever bytes your model uses and send it through. So for those of you who haven't got started with ML in mobile apps before, you might be thinking, well, I don't have a model, like what am I going to do? That sounds really hard. It can be complicated for sure. And hopefully some of the other talks here today will walk you through some of that. But my advice to you to get started is to actually use some of the retraining examples that we have. And you can go to a site called TensorFlow Hub to look at some of those models which you can retrain quite easily. And so I thought hopefully we have enough time to do this. That's why I've been kind of rushing through this because I think this is quite interesting. Let's try and give it a go right now. So how do you build a custom model? So first you have to find the training data, another challenge, which can be quite difficult as well. Then you can use a retraining mechanism to build a new TensorFlow model. In this case, in this example, we're going to use MobileNet. MobileNet is a series of models that are optimized for mobile devices already. Then we're going to convert it from TensorFlow model to a TensorFlow Lite model. And for those of you who haven't done that before, it's kind of counterintuitive. They're not completely compatible with each other. There's some operations in TensorFlow that are not supported in TensorFlow Lite. And so if you have a MobileNet model like the one I mentioned here, the conversion will be straightforward, just one command and it works. If you're using sort of a non-mobile optimized model, then it's not going to convert easily. You're going to have to go and look at those operations and either remove them or find substitutes. And then we're going to upload it to Firebase console. And I have a sample app here that's been built with the code that you saw before that we can try this out. Okay, ready? So there's many great things you can use ML for. This is probably not one of them. But for those of you who've seen the show Silicon Valley, there was an episode there about ML. And one of the engineers there, he built an app. And it was supposed to identify all types of food. You hold the camera and identifies all types of food. But it turned out all it could do was identify if it was a hot dog or not a hot dog. So we're going to build that today. Very practical use case. So let me show you what I've got to start with here. So I've got some training data. I'm not going to zoom in here, but basically it's just two folders, hot dogs and random. Okay. So in the hot dogs folder, what do we have? Bunch of hot dogs. No surprise. It's about 359 images of hot dogs. And then in the random folder, we have random photos. And there's just 66 photos in our random folder. Okay, so that's our data that we can use for training. Okay, and this is a way to retrain the MobileNet model. And what I'm going to do before I explain it is actually run it because it does take a little while. Okay, so we have nothing in our output. So I just took the training data in our images directory, and it's going to go and retrain this model, okay? So if it goes. While it's going, I'll explain to you what this command is. So it's using an image retraining Python script from TensorFlow Hub that you can find here, and you can just Google for it. And it just takes a bunch of parameters. So it gives, the input is the images directory that I said that had the two directories in it. The output files, so the output graph, which is the model, hotdog.pb, and the labels file, hotdog.txt. Training steps is how many training steps you want to do. The default is 4,000. I set it to 1,000 here because it won't finish before this talk otherwise. And then the last one is the important one. We're going to actually reference a model on TensorFlow Hub. In this case, we're going to use the MobileNet V2 model that I was talking about before, which has in this particular model has an input image resolution of 224 by 224. Okay, so let's see how we're going. Okay, because we kept the training steps quite low, it's finished. So this is the output of our training, our retraining. Hotdog.pb, it looks like it's about 9.1 megabytes, and hotdog.txt. And hotdog.txt is our label. So this is our directories, and we'll map to the output from the model. In this case, it's just hot dogs and random. It's pretty easy, but if you had 1,000 labels in there, there'd be 1,000 labels in here. Okay, the next step is to convert this regular TensorFlow model into a TensorFlow Lite model. Okay, and there's a command that comes with TensorFlow called tflite convert, and this is the command here. And again, I'm going to run it first, and then I'll explain it. Oh, actually, it was very quick. Okay, so hotdog.tflite is there now, so this is our converted model, and it's 8.8 megs. Okay, so to explain this quickly, again, it's pretty straightforward. It's going to take the output file parameter, so where we want to output our file, the input file, graph.def file, which is the model. The input and output arrays are actually defined by the model that we use, so the MobileNet model. So you can change them if you wanted to, but they're already set in that model. As was the input shape. The input shape is, again, the data that it expects to be input. And the actual data types are also set in the model already. So most of this information was already given to us by that model, and if you go to the website for that model, you'll get that information. Okay, so then we're going to go to our Firebase console. I'm going to create a new one. Just call it Devfest ML. And we're going to upload our tflite model to the Firebase console. That might take a second because I'm also on my mobile hotspot. See how it goes there. And then in the meantime, I'm just going to show you my mobile device. Oh, okay, that's pretty cool. Okay. That's not what I want to see. Okay. I'm going to deploy. Sorry, this is the code. So I'm just going to change the Firebase model name that we have that we're referencing here to this one that I just created. And oops. Now I'm going to deploy it. To this device. Okay, so you can see it says error loading model, and that's because I didn't specify a local model, and it's got to pull down the model from the cloud, right? So with any luck, in a little bit, it should have downloaded that model, and it should be good to go. So we'll just leave it there for a second. But of course, the best practice here would be to include some model in your actual binary, so there's something to fall back on. Don't have to, but it's up to you. So while that goes, let's try and see if we can go wireless because I need to. Come on. Wireless. Okay. So I'll set it up. Let's hope this works. Demo God's on my side. I'm gonna reload this because it's not working. Come on. If it doesn't, I'll have to fall back on the other model I created earlier. This one I prepared earlier. Is that what I called it? Does anyone remember? It is. Okay, so I'll fall back on the other one because this does not seem like it's loading. Okay. Okay. Okay, so here we go. Here we go. You see my screen still? Yeah. Okay, so you can see here that the model is outputting, you can see the text, some debug text. So it's got the likelihood it's a hot dog and the likelihood it's not a hot dog, right? So we're going to try this out. Okay. We're going to sell a hot dog. Pretty nice, right? So, and this is using some pretty quick training data. Skip to this one because they're a bit short on time, but is this a hot dog?
No.
Don't think it's going to be smart. Well, we'll try anyway. Focus. Focus. So it's pretty confused, I guess, is the answer. I think we're all pretty confused about that one. Okay, a burger. I don't know why I can't focus. So it's also, well, it's also pretty confused here as well, right?
Yeah.
It's just not good. So it's slightly below the threshold, so it doesn't quite think it's a hot dog, but it's getting close. So you can see our model it's not amazing, but it's trying. And then, oops. The last one I'll do is hot dog versus in a hot dog. So you can't get much more confusing than this. So you got fooled pretty badly. There you go. Okay, so that's the end of my talk. Just in summary, ML Kit, really easy way to get up and running using either the base APIs or custom models, especially if you're already using TensorFlow or TensorFlow Lite. And look out for the new experimental compression mechanism that's coming soon for custom models, because we're pretty excited about that. It's using a bunch of new technology. Resources-wise, the ML Kit docs are great, so I would just start there. If you're interested in the retraining that I was talking about, you can go to this, this article on TensorFlow Hub. In particular, though, if you're using it for mobile, like I've been talking about, there's a section at the bottom of that article called Other Model Architectures. And you probably want to pay attention to that because it points out that you need to use a mobile optimized model if you want to actually convert it to TensorFlow Lite, get it running effectively on a mobile device. And TensorFlow Hub, a nice resource to try out. That's it. Thanks very much.